developers. So today in this particular session we'll be discussing or implementing Firebase Realtime Database to our previously created MyNotes app. So first of all, to begin with, this session is brought to you by SIAM VIT, one of the best chapter in VIT law, and I Harivi is the host for this particular session. So before actually jumping right into the real-time database part, I would like to discuss or recap what we actually did in our previous section. So this is the app we are working with, the MyNotes app. So you see here this sign up fragment or Java file is responsible for the authentication part. So here we will be getting the email and password as an input from the user. You see here we are using text before that, sorry, edit text for that. And then for actually creating a user, we are also using create user with email and password, which is a Firebase feature using the authentication part obviously. And then here we are also using the reference. So here the reference is the real-time database part, database reference, a reference. So here I just implemented a very small or very small part of real-time database part for actually creating the user's reference, so that we can also store all the users detail in our real-time database. And in the login fragment page we will just log in sign up. We actually created new users, but here they will just sign in with the already previously created email and password. And in the main activity file we also changed one more thing, like that whenever an app opens, it will always start from the main activity file, right? So here what we actually did is, if there is no user already registered or already logged into our app, it will automatically go to the login up page. This is where they will create either sign up or login. So for the example's sake, I already created or I already signed up using one Gmail account. I'll just show that here. You see here, this is the Firebase console part, the authentication part. So I created an naruto@gmail.com, just don't care about the name. So here I just created, and this user is using our app, something like that. And the real-time database part for this particular project is this one. So it has user's reference, and this user's reference we actually created that from the sign up fragment page. So this is why we are using the real-time database part in our, this is why we used it in our previous session. So we created get reference users, and this will create automatically the user's reference part, and inside that it will auto generate a unique key value whenever an user signs up. So this will store two details of the user ID and username, and this is the ID, the same as this auto generated. So now the part what we actually want to work with in this session is that we have to create, or we have to put all our data, those entries, that each new entries we create, all those entries must be in the real-time database. So before actually going on to the coding part, let us just see something about the theory part, or let us understand what it really means, the real-time database. So starting with the real-time database. So what is real-time database? It is a Firebase feature, and it is like, this is an example of NoSQL database or NoSQL database, however you pronounce it. So this is also a cloud-based database. So here all the data are stored in JSON objects instead of the schema part what we actually use to implement in SQL or SQL. So I'm just gonna go with SQL, the pronunciation. So it also says that the using JSON objects allows us for fast responses, and it also makes a database really fast comparative to the SQL. And here obviously the authentication is needed. uh, this will come, or we will just see much more about this one in few more slides. So real-time Firebase database works even when offline with cached data then sync when online. And as for the dependencies, right now the implementation dependency as this particular version, it may be updated anytime soon. And this over here is a sample doc, and this is how a JSON object looks like. This is like a key value pair. So here the products is might be a key, and then the values inside that as another key and value pair. So this is like or this is how the Firebase works. This JSON object is just like this is just same like this one. So this over here is like a key, and the inside part has a value for this particular key, and which again has another set of values here. So these are all JSON objects. So Firebase real-time database part works mainly with the JSON objects instead of the schema. So to understand real-time database much more deeply, we have to understand what is NoSQL database. So again, for understanding NoSQL, we must know what is SQL. SQL, I guess it is just pretty much common. It is just like 2D data storage structure. All the data will be stored in different kinds of schema, and we have to do some normalization here and there so that there's no data redundancy, and so many different properties and stuffs will be there. SQL and non-SQL, there is NoSQL database has its own advantages and disadvantages. We will see much more deeply very soon. So now, what is NoSQL? It stands for Not Only SQL. Term was redefined by Eric Evans, and this is just the history part. And here it says they do not require a fixed table schema, nor do they use the concept of joins, and the relaxation for one or more of the asset properties. And these asset properties come in the database management. This comes in the SQL part. Like for maintaining the different schemas, we have to ensure atomicity, consistency, isolation, durability, and many other things. So we have to normalize so that we can optimize the data storage method. So generally speaking, in NoSQL database, our data will not be stored in neat tables or not neat structures. In fact, they can be stored in different structures like hierarchical tree structure, or like a column based or key value pair. But one thing most of them or all of them have in common is that they all are schemaless. That is, there aren't any restrictions on how the data should be stored, or what kind of data or what type of data should be stored at any point of the application. So here the need of NoSQL, the explosion of social media sites. So most of the social media sites actually uses NoSQL database so that they can access the data much more faster than the SQL database, where we have to worry about so many things. And then here the rise of cloud-based solutions such as Amazon S3, it also uses the same thing, same like the languages Ruby, Groovy, Shift, everything. And in the expansion of open source community, NoSQL solution is more acceptable to client nowadays. And then moving on, as I said earlier, there can be many different ways of how we should use the NoSQL database. Here it has been classified into 4 types: key value pair, column based, document based, graph based. So let's just start with key value pair. So this is like the JSON object that I showed you earlier. It will have first it will have a key and a respective value for that, and if the user want to increase the data, or if someone wants to decide something else, they can have another key value pair inside that, like nested. It is not going to worry much about that. So here it says the key value pair, right? So what actually happens is that each data or each pair of data has a unique key for that. It says, where is it? Uniquely identifies the record and is used to quickly find the data within the database. But in the SQL database case, there will be like, if you want to find a particular user's information or details about him, it will have a foreign key with some other schema in there. So we have to we have to get the access for that particular table, and we have to get the details from it, and we have to merge all those details and display. So this is what happens in the SQL side. So that is gonna be much more difficult than this one. So here all the data should be combined with a single unique key. Example is CouchDB, Oracle NoSQL database. We use it for storing session information, user profiles, preferences, shopping cart data. We would avoid it when we need to query data having relationship between entities. And this is what we actually do in SQL, so that we don't actually want to do it in NoSQL too. Like this is how we use foreign key, or we relate two or three other schemas altogether. And moving on to the column based type, it stores the data as column families containing rows that have many columns associated with the row key. So each row can have different columns. Okay, and Cassandra, HBase, Hypertail, and Amazon DynamoDB. All these things use this column based NoSQL database. We use it for content management system, blogging platform, log aggregation, and we will actually avoid this for early development changing query patterns. Okay, so basically in this column based type, so let us consider this one as actually these are two columns, these are two rows here, each with different types of columns. This has three columns, which again has some other column or some other different type of data inside there. So if you want to access any data from this part, let's say this particular dark green part, so this will be identified with the uniquely generated row key, and then we have to traverse to this one with another unique key over here. So this is also pretty much same like the key value pair. Here we are using row key and the respective column for that. So now to the document based database. This database stores and retrieves documents instead of actually key value. That specific data, this retrieves documents, and all the data are stored in some collections of documents. So in generally speaking, these just encapsulate or encode all the data in a specific encoding or coding part. Like say for example in JSON, and an XML file is also an example for document based NoSQL database, and we use it for content management system, blogging platforms, web analytics, real-time analytics, e-commerce applications. So, and for the complex transactions we won't be using it, since this is working with the documents alone. And coming on to the graph based part, this stores all the data again in graphical structure, tree hierarchical structure. So we have to traverse the relationships through each of the data to reach a particular data that we need. So this traversing is very fast as the relationships between nodes is not calculated at query time but is actually persisted as a relationship. So infinite graph, Neo4j, OrientDB, FlogDB, these uses graph-based database. It is well suited for connected data such as social networks, spatial data, routing information for goods and supply. So this is also generally the same. So here instead of actually having a key value pair or a specific unique value so that we can access the data, but here we are actually traversing through each data structures. So now to the advantages of NoSQL database. It is cheap and easy to implement, and here the data are replicated. That is replicated in the sense it has been the data is redundant. It is replicated to multiple nodes, therefore identical and fault tolerant, and can be partitioned. So when data is returned, the latest version is on at least one node and then replicated to other nodes. So what it says is that whenever we write data or we change the previously recorded data in a database, we have to change each instances of that. Like it says the replicated part, right? So it will have the same data in multiple nodes. So if we just change some part of the node and we don't change the rest of the nodes, it might be giving us an error. Not actually an error, it will give us a wrong data whenever a user gets the data from the database. So this can also be considered as the disadvantage of NoSQL database and no single point of failure. Like let's just say for an example, if there is an app where we can change the profile picture and it also displays the user details or our friends account details and everything. So here how many times we'll be changing our profile picture. So in this case if we use NoSQL database, whenever we change our profile picture it will take so long because it has to go and change the data in all the redundant multiple nodes. But in the case of actually reading the data from the database, it will be a lot more easier than the SQL database because again in the SQL database we will be using the foreign keys and other stuff to merge data from multiple schemas and then merge them and display it. But in the NoSQL database, if you want to get the details, it will just be a single key. So if you use that particular key, it will just get all the details. So let's just say in a app, the user just changes the profile picture for once or twice in a year, but he will definitely use the details or we will have to read the details on the database more often than we comparatively how much we write into the database for particular user. So one of the main drawbacks of NoSQL database is that it has many duplicate data here and there. So there's nothing could be done for that. And here they don't require a schema and there is no SQL. They are easy to distribute. And where to use NoSQL? NoSQL data storage systems make sense for applications that process very large semi-structured data like log analysis, social networking feeds, time-based data, and all these applications here is where we will be using reads more than writes. That is, we will be getting the data from the database more often than we actually write into the database or change the data in the database. To improve programmer productivity by using a database that better matches an application needs. To improve data access performance via some combination of handling large data volumes, redundancy, latency, and improving throughput. So the applications where even if some amount of redundancy is there, we don't have to worry about those things. So that is where the NoSQL database really picks up. So this again is just the definition of the real-time database that we saw in the first slide. This is the JSON object, and here let's see how the data is actually stored in the real-time database part now. Coming over from the NoSQL database, now we go to the real-time database. So here everything is stored as JSON object, and this example is like an hierarchical tree structure, but this is not actually a tree. We will come to that part in a bit, but before that, you see a L7W. This is a unique key that we didn't have to create. This is user generated. This particular key over here is user generated, and it will store its own value like that. It will just store many uses. We don't have to worry about these keys at all. And then database setup and use. For actually setting up a connection and reference, we can use again these same things. Like there are two ways. One is using Firebase Assistant in Android Studio, or else we can just go to Firebase console and go to the create database part, and it will automatically create it. That's not a big issue. All we have to do is just add some few dependencies in the Gradle file. And then reference. We will come to the coding part in a bit, but before that I'll just say what this means. Firebase database, Firebase database dot get instance. So this will just give us the instance of the current database. And child messages. So this will actually create a child from the root node. Let me show you. So you see here this unique key. This can be referred as child, but we will see more about that. So to add a new value, use the push and set value. DB reference is just the variable he created. Dot push set value friendly message. So whenever we use a set value, it will automatically clear the data stored in the database for this particular child, or whatever the DB references. Those data will be automatically deleted, and this particular data will be updated. Where friendly messages and object holding the data. So these are the listeners. We will definitely be using these in our code this session. And then database nodes. Firebase real-time database allows nesting up to 32 levels deep, but where possibly avoid nesting deep. I guess something is wrong with this statement, so just don't worry about this. But here it says it has 32 level deeps. So it is just that we can have 32 nested structures. In most of the applications there won't be need for 32. This seems pretty high. We will be using maximum 2-3 nested. Let's see about that. Also, don't use JSON arrays. And actually the reason for not using JSON arrays, we will cover that in another session maybe. And now database and security. By default, only authenticated users can read and write the database. So this is the real-time database console, and these rules are auto-generated. I will show you that. So this is the real-time database we have been working with. I will just go to the rules over here, and then it will show up. So this is the rules inside the real-time database in most of the applications, because whenever we create a real-time database for a Firebase project, it will ask us whether it should be in test mode or some other mode. Like one is permanent and another one is just for practice or something like that. So in this I selected the test mode. So this is only for rough use, like automatically after 30 days or so all your data will be deleted from Firebase if you are going to use in the test mode. So here it says now and some gibberish number or something like that. So here it will be different, as in the slides it says out not equal to null. This is that let us say we have a website or we have an app, and it also have an access for all the users in the sense the ones that did not log in and the ones that logged in. So we have to differentiate between them. So as for to differentiate between them, we will be using real-time database, but only for the logged in users instead of the users that haven't logged in. So for that, these rules are necessary. Auth not equal to null. Only authenticated users can read and write messages in the node or also access the messages from the node. And it can be changed. That's what these rules can be changed as per the application, but not recommended. And you can set up very complex rules where only some users can access data, like only the paid users can access the data for this particular solutions and those kind of things which we come across often, with cascading rules for the depth of nodes. And I also recommend you all to just check out this documentation. This all the Firebase documentations are really good. And that's it for the slides. Now let's just jump right in to the coding part. So now for the coding part, so once again I'll just show you the Firebase assistant. Just type Firebase over here and you will get the Firebase assistant to your right, and just go to the real-time database, save and retrieve data, and you just have to follow these steps. First you have to connect your app. Without even connecting to the Firebase, we would not have completed the authentication part, so it has been connected and the dependencies are set up correctly. If the dependencies are not set up correctly, it will also show the what are all the dependencies to be changed or to be added. So you will get insight for that just in the Firebase assistant easily, and only these two steps are the main things. Everything else will be pretty common, so you don't have to worry about that. So we'll just close that. So let's just start. First we have to create an variable database. Usually it will pop up. So database reference, I'll just create a reference variable. And then now where should we actually use or implement the real-time database? We will be putting the data whenever we add new entries to our list. So I will just go to the floating action button dot set on click listener, where we added the entries to the m example list. So in that I will just create this one. I will just first initialize this one. Okay, before actually initializing this, we have to get the user ID. Firebase user, Firebase user 1, and then Firebase auth dot get current user. Okay, I just keep making this mistake. It is the variable Firebase auth dot get current user, and that's pretty much it. And then I'll create a string user ID is equal to Firebase user 1 dot get UID. And then now we can go and initialize. reference. So now before actually initializing the reference, we have to understand what type of reference we are going to create. Like what I'm trying to say is that this reference part is the thing what defines or what point out the place where we will be storing our data or retrieving our data from. So now we are going to store it. So this particular code might be confusing for few if you're implementing Firebase database for the first time. Let's just try to understand it. Firebase database dot get instance, we will get the instance of the database and then we'll get a reference for that. And usually, not usually, in our case, our reference, our first reference other than the root one is this users. So we have to use that one. It is a string, so users, and then I will create a child of that. And this is why we got the user ID for the particular user, because we have to go inside this. First is the user, and next we will have the user ID, and inside of that I will be creating another child like a list, which inside of it will again contain each of the entries. I'll just show you that. So first is user ID, and then again a new child, and now I should name this as list, and it can be anything, it's just your wish. And then again I will be creating a child. I will just say m example list dot size maybe. So when there are 0 entries, m example list will have 0 size, so automatically 0 will be the child inside which we will be adding a name and description. Actually those are the entries, right? Okay, now I will just go to this one. Now after initializing the reference, we have to push the values. So for that we will be using hash map. So this is the hash map. Let's say hash map, and then I'm going to insert hash map dot put, and inside each of the child, like child 0, child 1, child 2, we will be having two entries, not two entries, two datas. Each entry will have two datas, name and description. So I'm just going to name this as name, and again this is the string that we will get from the edit box whenever the user clicks the floating action button, and here whenever he hits the add button in the dialog box. And in hash map dot put description comma description. So now we have created the hash map. Now we have to push or set the value in our reference. So set value hash map. So now I am going to add on complete listener. So this is just basically for checking if it has been added successfully or not. Okay, here we go, and inside this, and we get task here. So I'm just gonna use that task dot is successful. What do we have to say? Let's just create a toast message. in main activity dot this, let me say added to notes. Length short and show, and that's it. Now we have successfully created the real-time database path so that whenever the user creates a new entry, it will automatically be updated in the use Firebase. Now all we have to do is just go to the create example list maybe. Okay, over here. So in the create example list part, this function has been called the first. Like this is the first function, and after that we will be creating a recycler view, and only after that we will be selecting the selection list, and this selection list for deleting stuff. Actually in this session we won't be implementing the deletion part, but we can delete from the array list, but we won't be deleting from the database. We will implement that some other day. So this is, so now let me go to the create example list, and inside this, whenever the app opens, it will automatically create a new m example list. So now what we have to do is we have to fetch the data from Firebase. So for that, again I have to create a user ID so that we will know which user is logged in, and get UID. Now we got the user ID. Now database reference is equal to Firebase database dot get instance dot get reference. So again we have to think about this. What should we refer for? First of all, first reference will be the users, which is the second to the root node, and then instead of that we will be going for the child of this particular user's information. And now inside of this users, it will have three things. One is the user ID, and then user ID, and then password will be there, I guess. Wait, yes, user ID and then username is there, not password. User ID, username, and another thing will be here, and that is the list. And inside of the list is what are all the data that we want to retrieve. So we have to create dot child. So here dot of child of list, and I'll just close this. So now we have a reference for the list, but how do we access the data inside that? We will again add value even listener, new value even listener. And you see, whenever we are trying to retrieve the data from the Firebase Realtime Database, it will always give us the snapshot, which is it is a data snapshot. This is how we retrieve data. So all we have to do now is we will go to the on data change part, and first of all let me clear m example list, and then for data snapshot is the type, and this small lowercase data snapshot is the variable for traversing through each and everything. Snapshot dot get children. The snapshot dot get children will give us all the data inside this reference. This reference is that child 0, child 1, child 2, like that. So inside this I'm gonna create string 1, and I will be retrieving this data snapshot, and then child name, get value. After getting the value, it should be converted to string in Java. So this one, just the same thing again and again. Okay, and now we have to add these informations to the example list. So example list, which is an array type of example item. So I will just add them, new example item, and this item construct, actually this is a constructor in the example item Java class. So you see, this is asking for a name and then description. So we got the name now, and then we will pass the description also, and this is also over. And after actually retrieving all the data, we have to notify our adapter. So adapter dot notify dataset changed. So now the create example list part is also over. So now I guess this is pretty much it. Now we have implemented Firebase database, real-time database actually. So now whenever we open our app, it will automatically fetch the data of that particular user if the user has logged in, or if he has not logged in, it will automatically go to the login app page. And then whenever we add new entries, it will also add the nodes to the Firebase or update the data in the Firebase also. So now all we have to do is just install and run our app. So now one more thing is also there. There is this inside the create example lists. It shows that this get UID may produce null, what is that? Null pointer exception. So to actually do that, I'll just try this one. No, not this one. Another thing is there. Assert. So I'm just gonna say assert Firebase user. Okay, so here I'm not getting the Firebase user. Get current user not equal to null. This should work, I guess, I suppose. Okay, or else let me just change this to, let's say, Firebase user. Again, Firebase user is equal to Firebase, not just Firebase, the variable Firebase, Firebase auth dot get current user dot get UID. Okay, not UID, sorry. So now I'm going to use the above created variable Firebase dot get UID, and then after this I'm gonna assert Firebase user not equal to null. What does this say? This is always true. Okay, then it's not a problem. So now we have to change here also, right? Yep. So I will just add this one here also. Firebase user one not equal to null. Sorry. Okay. So now we also have to change this one. Here, this one. First, we are calling create example list, and inside the create example list, we are using these kind of statements, these Firebase features. So before actually using that, I would like to log in the user. So I'm just gonna cut this code and then copy it here. So now they will automatically be logged in or either go to the sign up page before calling this function. So now let's just try this out first. And now finally, for seeing an example, let's just go to a real-time database part, and we already have logged in, that is we have one user already, this particular Gmail. So now I'm just going to delete this one. Okay, not the users. Okay, let me just delete everything. Okay, now that has been deleted. Let me also delete this account. Deleted. Now, okay. Now let's just go to Android Studio. So now I'm going to screen mirror my mobile. So let's see here. This is our app. I opened it already. So now this is in login page and now on sign up page. So we have deleted our previous account. So I'm just going to sign up new one. And again this is gonna be the same thing. So now I hit sign up button and this takes some time, and you see a toast message appeared saying authentication successful, and at the same time real-time database here also users child of has been updated with an unique user ID now. So let's just open this and see what this contains. This has user ID and username as expected. So now I'm going to add new entries to my app. So let's just say this has first entry, alright? So in the description box, what do I say? Let's just say hey there. So add. Now it has been added, and you can also see here it created a new child, namely list. If I open that, it has another one child 1, which is the m example list size. Now we have only one entry here, so the name of this particular child is 1, and this has a description of hey there and name as first entry. So let me just add 2-3 things. What do we add? Let's just add Firebase, and then the description part implement. I will add it. You see here this Firebase real-time database gets updated automatically at real time. The name is understandable, I guess. That's it for this particular session. We have successfully created real-time database part. So I hope you can just change this app or upgrade this app just to whatever you want. Let's just see in the next session. Alright, then I will be closing the session now. Bye.